In this video we are going to see about how to create a linked list. So before that we will see what is a linked list. Linked list is a linear collection of the data elements, and these data elements are called as the node. So and we can say this is one type of a data structure, and it can be used to implement other data structures. Okay, so this will act as a building block to implement the data structures such as stack, queue, and their variations. We can say it is like a train or a sequence of nodes in which each node contains one or more data field and a pointer to the next node. Okay, so first we will see what is the node. So node, already I said, it is a data element, and this node is divided into two parts. The first part contains the data and second part contains the link. So link means it contains the address of the next node. Contains the address of the next node. So for example, this is the first node. Okay, so this is the first node. It contains the data as a 5, and it contains the address of the next node. So it is a link, right? So it contains the address of the next node. So for example, the next node is stored in the address space as 105, means it contains the address space 105. And suppose if there is a next node and it is stored in the 108. So 108 means it contains the previous node contains the address of the next node, that is 108, and here the value is null. And the next, then after this node, there is no node, means it will be the null. So like this way we are representing the node. So the node is divided into two parts. The first part contains the data and second part contains the null. And next we will see what is self-referential structure. So self-referential structures means the structure that contains the reference to the data of its same type. Okay, reference to the data of same type. So this is the self-referential structure. And in additional to the other data, the self-referential structure contains a pointer to the data that it of the same type of that of the data structure. It contains the same type as the structure. Okay, same data type as the structure. So next we will see how to create the node. So we will see a small code for creating the node. So first, as usual, we will use the header file here. So first we are using the header files. So here we are using two header files, stdio.h and standard library. So here why we are using the library means for memory allocation we are using the malloc function. So we have to use the header file standard library. And first we have to create the structure. So here struct node, and we are using two members here, int data and structure node, struct node char next. So it is a self-referential structure. Then next, inside the main function, so what we are going to do is first we are declaring one variable num. So the first field of the node is the data. For storing that value we are using the variable num. Then by using, we are going to print enter the data. So here what we are doing means we are getting the value from the user. So we are using the printf statement and it will print enter the data. Then by using the scanf statement, what we are doing, we are getting the value from the user, and that value will be stored in the variable num. Then next we are going to create the new node, and the new node is null now. So struct node char new node is equal to null. Then what we are doing, we are allocating the memory space for the new node. By using the malloc function we are allocating the memory space. So new node is equal to struct node char malloc size of struct node. The next what we have to do, we have to assign the value for that particular new node. So we are using the statement new node tends to data is equal to num. Then next we have to, so only one node is available. So what will be the link part here? It is null. So we have to assign that. So new node tends to next is equal to null. Then what we are doing, we are going to print the value of the node. So the data part value will be printed here. So for that we are using the statement printf. So is percentage d. So what will be the value for that percentage d? That is new node tends to data. Then we will return the 0. So here what is happening means, in this particular place we are getting the value for the num. So for example, I am giving the value as the num here. Then we are allocating the node, and we are allocating the memory space for this node. Then by using this statement, what we are doing, we are allocating the value for the data field. Then what we have given, new node tends to next is equal to null. So here it is null. Why it is null? After this there is no node, so this is the last node here. Okay, so the address part is null here. Then what we are doing, by using this printf statement, we are printing the value of the particular new node. So new node tends to data. So what is the value here? New tends to data, this 5. So the value 5 will be printed. So this is how we have to create the linked list. Okay.